Yeah.
So people aren't watching that.
Exactly, the timing's perfect. That's finished for the day.
Uh-huh. Yeah.
What was the final score? Portugal?
2-0.
2-0. Okay. All right, we're good.
Great. Well, good afternoon. Welcome to our fifth discussion, TOK Year 2. And today the question we are going to be discussing is, are visual representations always helpful in the communication of knowledge? Discussed with reference to the human sciences and mathematics. And today we're joined by Cody, Mr. Bovon, Artem, and Mr. Johnson. So thank you all for joining us, and please feel free to either raise a hand or interject when you have an idea you'd like to join in. And we'll try and make sure that all of you get plenty of time to talk and give your ideas about this question. Now, as chair, when I look at a question like this, I look at words like always. When I read a question that says always, I'm immediately drawn to attack those ideas, because I find that absolute claims like always are normally fairly easy to disprove. You just need to find one example where they're not helpful, and then you can say, well, I've answered this question. They're not always, because here's a good example where visual representations aren't helpful. But the discussion could end quite quickly there. So for the sake of developing a really good debate and a really good essay, I think it's important that we find a little bit of balance and think a bit more deeply about ways in which they can be helpful, why we are drawn to visual representations, why they crop up so much in teaching and learning in these areas, and what is it that's useful about them. And again, the powerful part probably is going to be the counterexamples, and if we can prove in some way using these examples that there are ways that they aren't helpful, then we're looking to think about ways in which you might have been misled by a visual representation, and ways in which you might think there are things that really can't be captured by visual representations. So let's start by considering the question, are they always helpful in the communication of knowledge, with reference to the human sciences? And by human sciences, we really are thinking about things like economics, politics, things like history. Well, history and TOK is often placed separately, but we can still look at things like archaeology and things within that world where we're trying to understand the history of humanity, anthropology, and other things like that. So to what extent are they always helpful? Let's think about examples, first of all, where we find good uses of visual representations. Could I call upon one of you maybe to give us an early example of a helpful diagram within human sciences? Is anyone thinking of anything to start us off?
Yeah, like one of the areas, like smaller areas of knowledge within the bigger umbrella of human sciences, is psychology. And if we're thinking about psychology, like our entire existence of a person, of a human being, or any other creature could be interpreted, and in order to understand the psychological pattern of it. And in a case like this, what someone can see would be the visual representation. So our appearance, style, how are we behaving, the gestures of the movement, the facial expressions, all of this are the visual representations of the internal processes. And some of them are really helpful, like usually if you have just the most basic emotional intelligence, you can understand that someone is feeling happy, or because they look cheerful, they're smiling, they are open, and like just genuinely express this happiness they probably experience emotionally. So this visual representation, which is not directly designed by someone to communicate knowledge successfully, still does strengthens this communication of knowledge. It really helps to understand what someone is feeling or experiencing. We can understand the outside world better through such visual representations in psychology. But as I could go like into more details and aspects of it later, and in order to try to understand what are the limitations of it, and why this big word always you mentioned, why this would not be applicable.
That's great. And when I'm thinking about the amount of information we take in visually, one of the things I'm aware of is that we have a huge optic nerve. It's a big part of our brain, and as a result, all of the information we process by other means, like auditory and smell and things like that, they are often overtaken by visual, which is why we often, when we're trying to get people to think about certain things that are not visual, we ask them to shut their eyes so that the imagination can come forward and things like that. Because otherwise we're distracted by everything visual. And an important part of our visual processing is for processing faces, because they're so important to human evolution to understand, is this person a friend or an enemy? Do I recognize them? Are they a mother? Is this a family member? And all those kinds of things. So visually, that's a really interesting point. Cody, you mentioned before about the impact of wearing masks.
Yes, so during the period of COVID-19, people were wearing masks, and that made communications during the classroom, during interaction with people, it make it really hard to understand people, even from like emotion-wise, and also like sometimes people need to read the lips of other people to like further understand or clarify like what they are trying to say. And I think like by wearing masks or like hiding that visual representations, it make it much harder to communicate with each other.
Good. One thing I want to clarify at this point is that when we're thinking about this question and representations, we want to think not just about the face itself, but about some representation of that. So the face is the reality. A representation would be some model or diagram or way of representing. The one that comes to mind is emoticons, or emojis. To what extent does that represent an emotion? So I'm trying to communicate with you by text message. We all are now used to this idea that I can add a smiley face at the end, and I hope to communicate something with that, some knowledge of my feelings or emotions. So my face isn't exactly a representation, it's a reality. But if I'm trying to communicate knowledge to you without my face, is there a way I could represent my emotions? Well, we've designed one and developed one, and we're all now more or less good at choosing the emojis, although there may be some that I read and I think, what does that mean? I don't know what this person means by that, through this visual representation of some emotion.
I would disagree with something that you said about face being the reality, though.
Okay.
Face is a representation of an emotional state. It is not the emotional state itself.
Right.
And when we are looking at words like always helpful in the communication of knowledge, we do have to remember that there are often times when we are deceived by someone's facial expressions or physical expressions.
Yeah.
And I think this does happen with people who are sometimes experiencing deep psychological pain, and they outwardly display a very, very different emotion, and no one picks up on it. They could be feeling like suicidal, and you would not see that in their face. I mean, they're not communicating this in any way. They're communicating something which may be the exact opposite.
Right.
So the face doesn't necessarily represent the emotional state that this person is actually feeling. I mean, I do agree that in the majority of cases, like in casual interaction, looking at someone's gestures and facial expressions does communicate an enormous amount of information. It does help you understand how that person is feeling. But when we're looking at the word like always, no, I don't think that that is necessarily true. And I wouldn't say that the face or the expression is the actual internal state. It is like an emoji that you are putting on
Yeah.
in many ways.
I think that's an interesting idea. It's not what I would normally go to as an idea of representation, but I get your point that it's not necessarily a simple reality. Yeah, it's not a typical example of a visual representation, but it's a good, unusual maybe line we could go down in terms of, are our emotions represented by our face, or is our face a conduit of?
Yeah, and since we're in the New York area, as a nice concrete example for us to think about too, related to Artem's point here, is there was a psychologist who had a team of grad students that observed family counseling sessions. In particular though, what they were researching was the body language, the facial expressions and these gestures. So much so that they watched the footage with no audio. So there was no spoken language involved in their analysis whatsoever. They were only looking for bodily cues, these visual representations. And what they discovered were many things about these couples and families. And the result of this, just to summarize the whole finding, is that these poor grad students, years later, when they were happily married, were so attuned to how important body language is relative to spoken language that they ended up often getting divorced because they would see these signs in their partners. They were so sensitive to body language compared to spoken language that it resulted in this kind of extra access of observation. So I think that the proportion we're getting at between just how important body language is compared to traditional linguistic communication seems to be right, yeah.
So, as you said now, like, it concludes to an idea that these visual representations are not necessarily helpful at any point on their own. They cannot exist independently, really. It's not just enough to look at something to interpret it in any way. You need to have other ways of communication, of knowledge. You need to have like the sound, or like even as you mentioned before, the smell. Like you can see the gas and like, oh, it looks dangerous, but when you smell it you realize that it's something else. Like there are so many things, and just by looking at visual representations, I think that it might be an oversimplification which really limits the understanding of this like larger concept that any information that we absorb, and especially if we want to successfully communicate it to someone else, it needs to be like a holistic portrait consistent not only of the visuals, but also supported by the other ways of communicating the
Fantastic. So that would definitely support the idea that it's helpful. Without the visual representation, we wouldn't get a holistic understanding. When I'm thinking of human sciences and visual representations, my mind often goes to geography and my geography lessons. Geography is a spatial science, and trying to imagine learning about where all the countries are and their interactions without maps, to me seems almost impossible to imagine. I can't imagine how a geography teacher would get by without use of visual representations. So it seems to me to be a good kind of core case to talk about would be geography. Can you imagine learning about the world without being able to visualize the globe and being able to visualize the relationship of one country to another? I wanted to throw in there the classic TOK quote, the map is not the territory. by Alfred, I might pronounce his last name wrong, but I think it's Korczynski. Have a look, it's a great quote, and my interpretation of that is, if you were to have a map that was the territory, it would be no use anymore, because it would be the same thing as what you are trying to represent. So the idea is always to have a map that is in some way a shorthand and is useful. And that means to some degree, the map has to lie. It has to either make it smaller with a little code. It's not really a lie, because you have to read the code and understand that this is much smaller than the real thing, so that it can fit in your room or in your classroom wall. A map is never the actual same thing. That's the whole point of it, is to be in some way a representation. We want that to be accurate. In the case of maps, I have in my classroom a Peters map, and I like that map as a projection because it gets the proportion of countries right visually. But some people would say, well, is it the best one? Because maybe some of the angles on there become distorted in order to do that. The best map would be a globe, but you can't put that on your wall so easily, so then you have this problem. And all maps, to some degree, they choose what to include and what not to include, depending on what we want from them. Political maps, relief maps that show mountains and the kind of depths and elevation of different parts of the world. So helpful for what would be one question. But in geography, I would say we could think of lots of examples where they would be crucial. Would anyone like to comment further on the idea of maps and how we map out things?
Yeah, well, I think two things that come up there in the case of geography is, A, it's not metaphorical at all, these representations. There's a supreme effort to capture the literal world as a representation. I think as we go on with further conversation, we're going to see some metaphorical uses of representations. But that's the first thing to highlight. I would agree, Mr. Barton, that maps as representations in geography are absolutely necessary, but they're almost always going to be literal in some sense. And then B, when we end up judging them, this is where we move more in the direction of mathematics, I think, because another feature is projections. And so when we're thinking about something that lives in three-dimensional space, like a globe, and we project it onto a flat surface, turns out mathematically we have lots of choices, each with sacrifices. There's no such thing as a perfect projection, but there's some maps that minimize distortion of angles, for example, and other maps that minimize distortion with lengths between Chicago and Paris, trying to keep that as accurate as possible. And so without jumping too much into mathematics, since we'll get there later, I think geography kind of stands out in the human sciences, perhaps, compared to some others we might look at in terms of that combination, having lots of representations, but most of them being more literal than metaphorical. And also when we judge them in terms of how helpful they are, that judgment, I feel like the heart of the judgment, I want to say, is largely mathematical. But then again, I haven't thought enough about geography. Maybe there are other reasons, like Mr. Barton was listing. But yeah.
I was thinking about economics as another subject, supply and demand graphs. If you've ever tried to, as a teacher, set a task for students to describe what's going on in a graph, or as a student, if you ever tried to put a graph into words without anything visual, it's actually really hard, because the amount of words you need to do to describe all the different relations, something that could be on a graph quite simple, the graph this is going up isn't good enough. In what way is it going up?
Another cliche, picture tells 1,000 words.
Yeah.
Yeah.
So trying to accurately capture in words something that visually you can, in a way, graphs are a great aspect. We could look at them in terms of human science, but also in mathematics. They're used in both. So visual representations in both areas are super useful.
Like with the maps and the graphs, visual representations overwhelmingly, like for most of the times, are the simplified versions. They are not always the replicas, but they are designed, created, and produced in ways which are easier to grasp rather than the written information or the other type of representation of it. And thus, like, I don't know, George Orwell in his writing, he tries to keep it as simple as possible so the most people can understand it and relate to it, and thus he really widens his audience and strengthens the effect of his writing. And so with visual representations, they are usually made more simple so more people could understand them, which is often the point of successful communications of knowledge. But here comes another aspect, like how is the depth of the knowledge we can communicate through visual representations is affected through how is it different?
I love your first point, Artem, and I think we should all pause and think about this a little bit more deeply. And the question, the TOK question behind Artem's point is like, are all visual representations necessarily simplifications? Or perhaps we could even say idealizations. And the joke that pops in my head immediately from the show Futurama, which I love, and in Futurama, they say that the TVs in the year 3000 are higher definition than reality. But it brings to mind Arden's point that any representation we ever come up with, whether it's the human sciences or not elsewhere, is it going to be the case that they're necessarily a simplification or idealization?
I think that's part, the way I understand the truth of that quote from before, the map is not the territory, is partly that it shouldn't be. That if it tries to be so faithful to the reality, then it ends up not being useful. The map is not meant to be the territory, it's meant to be some kind of communicative tool to simplify reality. I guess one question, based on what you said, you made me think about is that there's a depth that's lost. And is that depth about the complexity of the information? Or is it something, a different kind of depth? I hadn't thought of it in that way.
Even like, as you mentioned with the graphs, like when you start describing them in words, like in this process of analysis, you come up with probably deeper understanding of this graph as you kind of dissect it and really analyze all of the meaning invested in it, when the visual representations are like the shortened versions of what would be maybe the written version of the representation of this information. And you probably would take longer time and pay closer attention reading this and trying to understand this information. But here comes like a completely different aspect, like how much do you care about this information being communicated to you successfully? Like as teachers, you probably experience having students who are not so passionate or just don't have strong motivations to learn something. And visual representations would be like a really brief and probably the most useful recap for them to understand the sum of the information, rather than just skimming through a text, not paying attention to it and not understanding what does it say.
I love to use diagrams in my teaching. It's hard to say to what degree my diagrams may have misled students over the year. When I think I'm being super clear and I try to explain something philosophical, which is often in my head, I've put this thing over here and this thing over here, so I'm trying to explain it to students. And they don't know what's in my head, and I'm trying to get it across. And sometimes I abandon a diagram or something, but this doesn't work. I was trying to explain something, but that's how I saw it. And then I'm trying to get this across to you, but they don't see it the same way, so the diagram just doesn't
I
make sense.
think certainly when you're talking about mathematics, you can have equations that are represented graphically, and for certain people, it's much easier for them to look at curves
Yeah.
on a coordinate plane and to comprehend, oh, this is just where two lines meet, than to look at some numbers and letters on the board and saying, oh, what's the solution here? Like, you can draw the intersection of two curves and say, okay, that intersection is the solution. And for some people, that definitely communicates the knowledge much more easily than any mathematical workings that you can show on the board.
And I do think it applies for like other areas such as like computer science, which is like it's sort of like a marriage between mathematics and human science, where like in machine learning we have like cost functions, which is like measure how much like a model is like off with like the actual predictions, and like some cost function is better to just like put it on decimals and just to see how it works instead of like plugging in numbers or like seeing how it like work with other like numbers or like functions. So like I think in that sense it helps.
Right? So that's in computer science that the cost function is represented visually.
I find that it's helpful to represent it visually, to look at it visually, so you can understand how it works, like, and then you can apply it later. So.
Fantastic.
Yeah.
So one thing I was thinking of mentioning, and I think it could be something that you develop at the beginning of an answer to this question, is it doesn't have it there in the question, but I think hidden in this question is compared to words. So it says, are visual representations always helpful in the communication of knowledge? Well, what else would we use? And our default, I would say, is language. This is what we're using right now. There's a strange irony, we're talking about images and words in a conversation here, auditorily. You can see us, and we could perhaps hold up some diagrams and things for you, or try and draw them on behind. But visual representations are obviously helpful in the communication of knowledge. Otherwise, we wouldn't have whiteboards in the classroom, we would just talk. So the question then is, compared to words, it's kind of hidden in this question. Are visual representations useful compared to language? So as a philosopher, one thing I would mention is that we always remember that language is not perfect for communication. And whenever I choose a word, I understand something by that word, and I'm hoping that you understand the same thing. There's a loss of fidelity even whenever I'm communicating in words. And that can be multiplied in an international school where people might have learned different understandings or meanings of what does that word mean to you? Well, there's a similar word in my language and therefore I think it means this. So sometimes, yes, it's true that we could talk about some of the limitations of visual images and representations, but I don't think we should lose sight of the fact that we're also comparing that to talking. And
So could we communicate this discussion visually?
that's a great question.
I don't know that our discussion can be communicated too accurately using only visuals.
Yeah.
Yeah.
I think once we get to the math part, I would argue we could do it completely with representations.
I'm wondering if we just turn this into like a sign language podcast, would that be like all visuals or all like
That's interesting.
Yeah.
That would count, I think, as linguistic. And if we wanted to define visual representations as non-linguistic, then sign language would be excluded. But it's interesting because it's a visual representation of a language. So I don't know whether I'd want to cut that out or not.
The human, while we're still hovering around the human sciences, this is bringing to mind, I think, a key point that we're all slowly realizing perhaps, that it's not a hard and fast distinction between linguistic communication and visual representation. There might be more of a continuous spectrum at play here. And ironically, the next example I would want to mention is the science of language itself, linguistics. And what's nice about this example too, compared to geography, where we thought about collapsing 3 dimensions into 2 dimensions to make our maps. In linguistics, basically what we see is the one-dimensionality of language. After all, I think we would all admit that these symbolic strings of characters that we have in all of our human languages are restricted to linear single dimensionality, really. And part of the spectrum is maybe what visual representation at the most basic level gives us is an opening up to more dimensions. And ironically, in linguistics, the kind of godfather of linguistics, at least in this country, Noam Chomsky, famously used tree structures in his theorizing. And really, I would argue, all of Chomsky's trees give us is access to the second dimension. And he's analyzing language itself, which is the amazing thing here. But what the tree diagram gives us in his analysis is this wonderful communication of the knowledge that there are certain hidden plugs in our sentences that remain empty sometimes, and they can all of a sudden become occupied through these movement rules that Chomsky discovered. And it's best to see this visualized in 2-dimension using trees. So I think in the case of linguistics, what that really highlights is the same point that we're all kind of moving slowly to. Like, maybe there's not a huge difference. Cody mentioned sign language now, which can be very dynamic and kinesthetic. Maybe it's more of a spectrum between linear linguistic communication and typically higher dimensional representations.
See, I'd like to see these trees to get a better idea of what you're talking about.
Yeah, so luckily, thanks for saying that, Mr. Ravon.
Let's have a look.
Perfect teacherly moment, yeah. So, go ahead, Anton.
What we mentioned is like there, I think what we are like
Yeah.
trying to say it as is that like there's truly the difference between visual representation
Yeah.
and other types of communications of knowledge
Mhm.
is like vague, and there is no really that clear distinctions between them, like
Mm.
what Cody said about the sign language, or I don't know, the subtitles, would they be considered the written information? Is it a different way of communicating information
Mm.
if the words are written and are technically visual?
Mhm.
Or like, is it truly a visual representation as it's like a support to the information we communicate to others through their hearing
Mhm.
abilities?
Yeah, yeah, absolutely, absolutely. Yeah, so a tree structure just looks like this. Tree structure. See the hole, the slot at the bottom? So Chomsky would just notice that, like, in a normal declarative sentence, there could be a hole, but if we want to rephrase it as a question in English, maybe the hole gets plugged in with a certain question word. Things like this. Things that are kind of obvious. The beautiful thing about linguistics is everything's kind of obvious because we're all native speakers of English, for example. But when you think about it scientifically, then things get a little bit more challenging. Yeah, are we gonna maybe move to mathematics?
Can I just like briefly circle back
Yeah.
to psychology with like an example? The example is the teacher of communications in the University of California, Los Angeles, UCLA, assigned his students the project about the personal style and how it can change throughout the lives of humans with the significant shifts in their lives, with some severe impact of different experiences, like a loss of a loved one or a new job, things like this. And for example, Mr. Vaughan and me were wearing orange, and usually orange is seen by people as something representing like the cheerfulness and like the positive mood and something like this. But as you said, Mr. Vaughan, it is not the reality. There is much more to it, and when there is certainly the easiest way to interpret something, this visual representation of us, for example, it doesn't mean that that is actually what we are experiencing. And when it appears so in this like first impression, and usually the first impression is what we get by using the visual information. This is more complex, and only by understanding other aspects, for example, knowing us as human beings and understanding some of our background and the current development situations in our lives, only this could actually provide something truthful about this interpretation and either prove it or disprove it.
Thank you. I think it is a good time to move forward onto mathematics. If we do have ideas later on that occur to us related to human sciences, we could. We talked a little bit in human sciences about some misleading aspects. We talked about the iceberg. I think Mr. Johnson mentioned that in psychology. What aspects can you think of in mathematics, if I could put this to you, Mr. Vivon, where visual representations might be misleading or not helpful?
Well, there's always the issue of the classical mechanics in physics. If you just look at basic mechanics and motion of objects, visual representations are very, very useful because it's something that we're accustomed to seeing, right? You're accustomed to seeing something fly up into the air and fall down. You're accustomed to seeing a car moving, people walking, and all of that. And all of these phenomena can be represented visually and mathematically as well. And I would say that for the vast majority of people, seeing something, some type of visual representation of a mathematical equation that represents the motion of an object is very, very useful. By being able to actually visualize what is happening. And just looking at an equation is, for most people, probably not as useful as seeing some type of picture or diagram. On the flip side of this, I guess once you get into more advanced, like modern physics, it's the math itself that describes the reality. Well, the math always is describing the reality, but the math does a better job of describing the reality than any visualization that we can come up with.
Right.
Because I think once you start talking about quantum physics, actually trying to come up with a visualization of it is not as useful as just basic mathematical formulas that describe what is happening.
Mm-hmm.
It's like, I don't know if you can come up with good visual representations of what is happening in particle physics that describe the reality as well as the mathematics itself.
Well, there's a few things going on there, and maybe the first thing to highlight, in particular with quantum physics, is the nature of it being a microscopic theory. So there's something intrinsic to the theory being so small and fine-grained that perhaps is just an utterly different scale than normal everyday life, which makes perhaps visualization slightly intractable. But one cool example that I've seen about one interpretation of quantum mechanics actually uses an everyday object, perhaps not every day, but a Tibetan singing bowl full of water, and you rub the Tibetan singing bowl to make it sing as the monks would do. And what it demonstrates is the water in the bowl begins, after the vibrations ripple, and you have these water droplets that quite literally dance on the surface. And what that nice, back to representation, like this is just a real life phenomenon now. To what extent are we representing anything? That's just the world. But in any case, it kind of macroscopically represents one of the interpretations to the theory, namely that there are waves, and the waves kind of pilot the particles around. And so I think that's one aspect of what's going on there. But another thing you mentioned earlier, Mr. Bravone, is whether or not, so back to this distinction of where a representation might be non-rigorous, so referring to the math of physics again. Like if you get more advanced, and I'm not so secretly a physics student, so I remember this. I remember when things became pure math all of a sudden, out of nowhere. We no longer had our idealized spherical cows, you know, and we're like, where are all the pictures? And it's pure math. But perhaps that's not just to make it more rigorous. There are a few other things going on too, like multiple dimensions, again, too, back to dimensionality. Like everyday normal space that we're used to has our 3 macroscopic dimensions and one of time, and some of these other interpretations of the quantum theory entertain countless dimensions, let alone 4.
And how do you represent this visually?
And how do you represent it? So it's not, but it's a very subtle distinction there, because if we were to represent it, it's not that the representation is intrinsically less rigorous than the pure math or algebra. It's just that because of the scale we happen to live on, or because we're so familiar with 3 dimensions, that we fail to be able to see something beyond that. So I think there are a lot of subtle things going on here, but I will mention a famous example in the history of math and physics related to what Mr. Bravone is saying, is this mysterious, not so mysterious, they're all quite well known, but this group of French mathematicians that published papers under the pseudonym of Nicolas Bourbaki. And they tried to, 20th century, refound all of mathematics on a rigorous footing. And one of their key principles was to remove all visuals, all representations from their textbooks, which were about this thick each, and they had volumes and volumes of these. None of them had any representations as you flip through them. It's just line after line of linguistic communication along with algebra. And similar to what you were saying, I think their criticism there, their allergy to visual representation in the AOK of mathematics, is in essence they thought that visuals were too artistic in nature, and with art comes, almost by definition, the phenomenon of multiple interpretations. And for them, the sense of rigor in mathematics and physics was we need singular intended interpretations. And they thought that could only be preserved in the algebra, in the equations, and a little bit of French language on the side. So just as we kind of lead into like how visual representations can be helpful, yeah, how can we react to Bourbaki? Like, what's going wrong there?
I don't know, I
Yeah.
would think that most people opening up those books might be a little intimidated, and all they see is a little bit of French language and a lot of mathematical equations. They could probably understand it a lot better if there were some visuals in there.
We tend to think so. I wouldn't want to give my students a textbook without any diagrams and try to teach them science or human sciences or physical science or any kind.
Yeah, well,
without diagrams.
there's a subtle point there too, though, because let's back to philosophy of education and pedagogical concerns. Like, what level of student are we imagining? You know, like if you open up a textbook from the Bourbaki seminars, none of those members would ever imagine a high school student, let alone an undergrad student, trying to engage it. It's only for the most advanced, really, and for their own kind of religious fervor, you know, just to kind of give this final pronouncement of the state of mathematics. And so it's not, like, who are they communicating to? Like, I bet some of those guys, without exaggeration, would say, oh, they're communicating to the gods. You know, like, that's the best reader, that's their viewership.
Yeah.
I don't know if that's one or multiple, it's up to the tradition, but so I think there's a nice distinction there too. Like when we communicate knowledge, as the PT tells us, the PT is not telling us, are we communicating to just kind of everyone? So we have this teacher problem all of us teachers have of differentiation. It's like, okay, now we need to present material in some kind of way that's accessible to people on all these different levels coming from all these different directions, or do we have like a very particular target audience in mind? And it's agnostic about that, so I think we need to be a bit careful there.
And I think if we like start to circle back onto the education point, there's
Yeah.
like almost like target audience for like visual representations, right? So for student, they're different type of student according to some theory: auditory, visual, kinesthetic, and written and reading like kind of linguistic student. So like maybe visual representation is best for just like a singular type of student. So but like some articles just mentioned that this type of type of student is like lack proof that they actually like learn best through this method. But it's like again to that point, maybe it's best for like a group of people only.
Great. So in answer to the question always, we could then add in the question always for everyone or always for some people. Maybe there are some people who will always lean towards.
Yeah, and according to official statistics, approximately 65% of people are visual thinkers. But then there's 35% more who are not, and for whom the information communicated in other ways than through visuals would be more understandable, more digestible, and this already it becomes like another proof that it isn't always when the visual representation helps with the best possible communication of knowledge. But also, like, if we think about other aspects and including that, like a lot of children, they don't like reading when they learn how to, and they need pictures because it is simple, the visuals are, I think, as we kind of agreed together, almost always or really often, the visuals are the easiest type of information to interpret. You see it immediately, and that is like the shortened version composed of a lot of other factors going together. And in math, like the graphs and some equations represented in visuals would be a really helpful way to communicate the information, but are they always the most useful ones? No, because it's not enough sometimes. Like, that is why in math and in other sciences there are mnemonic devices which help people to memorize some more difficult concepts, and this isn't a visual representation of information, but also simplification, which gives people, which endows like this, people who needs to be communicated with this information, it endows them with the basic primary understanding of the information that they need to absorb, and allows them to use this information as they communicate it to others or to the person who shared it to them with them.
Fantastic. Yeah,
I was just gonna, go ahead.
I was thinking that your example about children's books, and then I was thinking that when we think about a novel and when we think of that as being a higher form of literature than a children's book, why do we generally have fewer visual representations in fiction for adults than for children? You can find exceptions. There are huge, great works like Lord of the Rings, which start with a map at the beginning so that you can help imagine where all the different characters live and move around. But in general, part of the point of not having the representations there is to activate the imagination. So we enjoy our book partly because I get to create some aspects of that from the text. So you might imagine the main character in one way, and I've got a different imagination of what they like. And the skill of the writer is to make deep, great sketches of characters, but we don't necessarily want to add a picture in the book to then say, well, this is exactly how they look. But in other parts, in other kinds of areas, like in human sciences and maths, we're often looking for more precision now. We don't want you to end up with a different idea than what I've got, because we want communication, we want it to be faithful, so you can visualize the same thing I'm visualizing. So
Isn't that interesting, now that you said it like that, for precisely the same reason, in literature, we're removing representations to activate imagination, whereas the Bourbaki mathematicians, they're removing representations precisely to minimize our imagination. They just want to see the algebra and really appreciate it for precisely the thing that it's saying, without, this multiple interpretations that an added visual might bring to the table.
I mean, I was thinking that I've been using timelines a lot recently. In year one, TOK, I've been talking about history, and I quite often revert to that spread out time on an x-axis from left to right. But why left to right? It's just it's a convention. There's nothing true about it. Time isn't moving in any of these three dimensions. But I need to put it into a 2D surface, and that's the way I normally choose. So we end up imagining time in a very visual way as a result of things like timelines. But I believe from physics, it's a dimension in some way. I don't know if I could explain how, so my physics knowledge isn't as good, but trying to visually represent time, I don't know how helpful that is. Right? Any thoughts on that? Does anyone know much about time?
Yeah, I mean, that's a good example of, again, kind of compressing something into an X number of dimensions when perhaps it's involved more. Yeah, absolutely. So we've yet to say, or we've yet to kind of emphasize the productive value, how helpful visual representations can actually be in mathematics.
We did talk about maps though. Perhaps we will talk about the famous tube map.
Which?
The London tube map, sorry,
Yeah.
the London Underground.
Right, so the London Tube map is famously a fantastic map as far as maps go.
Beautiful.
Beautiful, gorgeous, polychromatic, every line, every stop included. And what's nice about that, thinking about it mathematically, and again, the reason when we judge it to be good, and it's known to be good, that judgment is coming from a mathematical lens, I think. And even more subtly, it's like we can approach it mathematically, and someone could look at it with different intentions or different purposes, and like, oh, this is an awful map, because it's wildly wrong metrically or geometrically. But according to topology, its graph, its connections, which is usually all of us people, that's all we care about, navigating a subway system. It's great. It's got all the connections. Everything's in the right place. So it's topologically very helpful in communicating the knowledge, which is in terms of the London Underground. Yeah, but if we analyze it in a slightly different way, we're like, oh yes,
It's good in one way and it's bad in the other, is what
Yeah.
you're saying. If you want to know where one station is relative direction-wise to another, it's very good. But if you want to say, oh, look at this, how long is it going to take me to get from point A to point B? Well,
Right.
then it's a terrible map, because
Right.
you're looking at it and it's completely distorted, and you think that you are much closer than you actually are.
Right.
It's like,
Yeah.
oh, the map has them here, and then I've already traveled from here to here, so it must only be 5 more minutes.
Right.
So in that way, the visual representation is terrible, and it actually does you a disservice
Yeah.
when you are
It could
figuring
be-
out like how long your time is going to be.
Right.
But in terms of, oh yeah, where I am located in London, okay, well, that's good.
It is the limitation of visual representations that sometimes they could only target one of the aspects of understanding. And like that is why some of the big pieces of information which are being expressed through different graphs need to have several ones which are each showing the different aspect of it.
Excellent. Cody, I wonder if you could mention at this point, so we're talking about positive examples of communication in math. Could you tell us a little bit about the project that you worked on and what you were aiming to do?
So yes, one of the projects that I have helped to work on was Penrose, with Mr. J, of course. So we basically collaborated with Carnegie Mellon graduate student to help them build this projects that they are doing. Essentially, is this Penrose platform is to develop a diagrams with like simple mathematical equations. The argument was that diagrams were just available, who want to make like diagrams only available to like experts if they want to make it. They want to make it like available for people who doesn't have like a very strong knowledge within the domain or the field that they are trying to illustrate or visualize. And so one interesting point of Penrose is that whenever we're trying to make a diagram, there's always a variety. So we have constraint, we can place like specific constraint within this diagram, but there's always like a variety within like how the shape, the size, or how it could look. And I think it's like very interesting to be able to see like how those constraints work and how like visual representation can be looked different way. And yes, also yes, Mr. J, I can see
Yeah.
your
As an
existential graph.
As an example,
Yes.
graphical logic for online viewership and real life viewership. Yeah. Okay, so, and math teachers too. You know, Cody and I worked on this, and as a visual representation, we could write this symbolically in logic, and it would just say P or Q. But the cool thing is when we draw it as a graph, we get 3 interpretations for the price of 1, which makes things even more fascinating when we go back to the original critique from Bourbaki. Because again, remember those French dudes, their whole allergy was, oh, if we add visuals to math, then there's too much likelihood for multiple interpretations, and that's bad. We want singular interpretations of our algebra, so let's keep everything algebra and avoid the representations. But the irony here is sometimes, and not only sometimes, this often happens in mathematics, we have equivalent expressions. So much of math is showing one thing is the same as another thing, right, math teachers? and logic is full of equivalences, but when we write out logic symbolically, we have to write 3 things that mean the same thing in 3 different ways. But when we write it as a graph, we can write one picture which captures in one full swoop all 3 of those interpretations. So there's something really interesting going on there, because Cody and I were working this stuff. We're like, hang on a second. If mathematicians are worried about multiple interpretations, maybe that's too big of a worry, because sometimes there are multiple interpretations of the same type of phenomenon, but all of those interpretations are equivalent, and we can prove that mathematically. And there's different kind of angles. So that graph, once again, we can read it as P or Q, but what else can we read it as? We could read it as if not P, then Q. Okay, logic exercise for the viewers, yeah. But they all mean the same thing, and it's all in one picture. So we get this added power, back to Mr. Martin reminding us of the common cliche in most of our cultures: a picture tells 1,000 words. So again, I think that original critique that we kind of saw in mathematics might be a little overly strong or overly fearful and thereby blocking the potential of some of these graphical approaches.
And I think if something, maybe multiple interpretation could be its advantage, because like we can see like how multiple of like the interpretation can be its equivalence just through like a picture. And I think that's like very helpful in communicating some kind of knowledge within like areas of math, for example.
Yeah.
Fantastic. Well, we've covered quite a range of different points of view. I'm sure you can think of other examples if you were to dig through the human sciences and mathematics, but at this point I'd just like to say thank you to the panel for all of your different suggestions and ideas, and to all the TOK students, good luck with your essays. Think it through, and hope we've managed to provide you with some good stimulation to get you started.
Yeah. So, from our large audience, which no one can see right now, but from the large audience, any questions out there?
I did have a question. Is that today we almost assimilate everything with a visual representation. If I told you a number, you would immediately think about how you write this number and how you write this number. Do you think that today this generation today could do anything if we were taking out every single visual representation that has a life? Do you think we will still be able to do what we do today if every single person suddenly became blind?
Yeah, I thought that it might be a fascinating twist in our conversation if we did have someone here who was blind to actually discuss his experiences in terms of communicating knowledge. Because I was thinking, when Arkham brought up the children's book.
Yeah.
Children's books have so many pictures in them. Like you sit there and you say rabbit. It's like, oh, there's a picture of a rabbit. Well, like, okay, how does, if you are unable to see anything, it's like, how do you get this concept of kangaroo or something like that?
Yeah.
Like, what is it other than just a word to you? I guess you can get some description of it, but I would think that even when they're trying to train computer systems on kangaroo or rabbit, they're showing millions and millions and millions and millions of pictures, right? They're teaching the computer visually of what this thing is, but like, I'd love to hear the opinion or the
Yeah.
thoughts of someone
Yeah.
who is unable to see.
The amazing thing, like we've been speaking, not as if we forgot this, but it's easy to forget that our sensory modalities are fluid once again. There's not a hard and fast distinction between them. And so there are these cutting edge technologies that put these pads on blind individuals' backs. And through, tactile sensations, the sense of touch that they do have on their body, in their mind's eye, as it were, all of a sudden they were kind of visualizing certain things that the neurologist would program into the machine. And then, I have one student this year, I won't say her name, but she's proudly a synesthete, and this is another thing we can think about too, people with synesthesia, and it comes up, and again, to be proud of our local New York City. Every year there's a memory competition in New York City, and a lot of the best memorizers are synesthetes. So they have this condition of their sensory modalities kind of interchanging. The most famous example would be like tasting colors or feeling numbers. And so like they're memorizing digits of pi, and it's much easier for them because instead of, what is it, math teachers, 141259, uh-oh, I've already forgotten.
Yeah.
But, one is like, gives them pain for this synesthete, and then the 4 makes them feel warm. And so they go through this roller coaster of emotions as they're otherwise just regurgitating pi.
But presumably the two synesthetes don't necessarily have the same feeling. So
Right.
for one person it's like, oh 9, the fuzzy number.
Yeah.
And the other one's like,
Yeah.
it's spiky.
Yeah, what are you talking
Yeah.
about? Yeah. But so I think, I don't know, because of, I like the question, but with these amazing new results with neuroplasticity, I think there's not as much of a problem there, perhaps. Yeah, that would be my contribution.
Yeah, but just the ability to see and just experience the visuals around us are crucial for our existence. And the question that you, John, asked, I do believe that the world would be completely different if just the majority of people were blind, and if the entire population was blind, just the reality would be completely different because the progress would go differently. The beliefs and values of humankind would be different. It would completely rewrite the way we live our lives.
That's interesting. There's a series that's on a popular streaming service called See, and in this hypothetical future world, people have been destroyed by kind of an apocalypse, and there are some survivors, most of whom can't see, and the minority who can see are kind of maintain a visual knowledge. They're able to read and other things that the others don't, so they're feared by those who can't see. It's an interesting thing. It's something that you could explore and take that further. I think the point of Jonah's question to some degree was whether we, because of the age that we live in terms of our access to images, the very easy access that we have with search engines and things like that, we just bring pictures, throw them next to the words, make a PowerPoint so much easier than we used to be able to do. And things like Instagram, we have a very visual orientated social media culture. You could argue Twitter is a good counterexample to that non-visual medium on the whole. But yeah, are we losing something the previous generations had as we gain in our visual abilities through all of this technology to communicate? Do we become dependent? Any other questions?
I mean, I had a few, but I'm trying to decide which one I like the best. So at one point, I know someone was talking about how visuals can be used to mislead. So it brought to mind my least favorite branch of math, which is statistics. Actually, I'm starting to like it more and more. So I wrote, statistics can be used to mislead. There's even a famous book called How to Lie with Statistics. One of the most common examples is creating a bar graph or histogram where the vertical axis does not start at 0. This causes the bars to look closer in size than they really should. To what extent does the intention of the creator of the visual play a role in the helpfulness of the figure? It obviously doesn't help the viewer who is misled by the figure, but could it technically be helping the creator achieve their goal? So even though it's misleading to the viewer, could it be helping, right? Could it be used for sort of evil intentions, I guess? Right?
That's great. And one thing in the notes that Mr. Johnson wrote about was about the word communication. When you're looking at communication, you normally want to have fidelity between what I think and what you think, but here you're talking about the helpfulness maybe in giving the people who create the visual a certain power over those who are receiving it. Misleading propaganda, selling something. I could think of a few possible
This
examples.
kind of sounds like the map that you were discussing of the London Tube. It's distorted in a way, which doesn't accurately represent distances, and that's basically the same here. It's like you can create some graphs and you can distort them in different ways to make, well, you know, they look to be just about the same, where in fact they're widely different.
So that's an example of something that's user-friendly though. They're taking out the complexity to make it easier to handle. Whereas I think in the kind of
think what they're
cases,
doing is that they're changing the visuals to present their own point of view, whereas if someone else created the graph, it would create a completely different, you'd be presenting a completely different point of view.
Yeah, and that's a clear. I love that case of the bar graph being truncated.
It's one of the most common examples.
Yeah, because I mean that
y-axis abuse.
right axis of abuse. Yeah,
Because you can make it look like the bars are like big, when it's like real, you know what I mean? If you make
Right.
the bars bigger, they're almost the same, or,
Yeah.
you know, yeah.
So it completely distorts their
Mhm.
proportion, and so I think, yeah, in contrast to the London Tube example, where what we changed there in terms of the background purpose is a whole branch of mathematics, basically, from geometry to topology. But there, I mean, it's the same mathematics, and there's just a real cheat in the sense that it's making this truncation, and if the viewer is not aware of that mathematical cheat, then yeah, awful consequences, and voting for the wrong person, perhaps. Yeah.
There's a whole science of trying to interpret these things accurately and trying to make sure that we're trying to communicate well with graphs and visual representations. Sometimes it's deliberate that people will exploit it. Like you say, it has a lie with statistics. There are books that people are promoting because of the power that gives you to get people to think a certain way. But it's also really useful for students to look into so that they're not misled. Sometimes it's by accident. People like choose a 3D graph and forget that that's going to make things look square.
Yeah.
It is happening to all of your statistics, and they don't represent that right.
Yeah.
Yeah.
Statistically speaking, they're getting better.
Right.
Yeah. All right.
Well, thank you for your questions.
Thank you,
We're at
guys.
our time,
Thank you.
so appreciate your time this afternoon. And
All
that's
right. Awesome. Let's clap for ourselves.
Yeah.
Thank you, guys. Awesome.